Hello, everybody, and welcome to becomeatechpro.com. My name is Ademola Olaoti, and I'm a trainer here at becomeatechpro.com. So, ahead of the February 4th class, we've had some questions coming our way and thought it would be a nice opportunity to run this introductory class so that we can address these questions and many more other issues that require clarification. So hopefully at the end of this session, we'll be able to all know answers to these questions, like what is DevOps? Why are organizations embracing the DevOps methodology? What makes the DevOps profession very attractive? Who can become a DevOps professional? And are there many DevOps jobs out there? So these are some of the questions that we'll have answers to at the end of this session. So I'd like to start out by trying to narrate a situation to help us understand the relevance of DevOps. Okay, let us say Lagbaja goes to the store, right? Goes to the store to buy some plants from, let's say, Home Depot, bought some plants in vases, right, for transplanting. And he took these plants home to transplant, and some of them were successfully transplanted, right? After a while, they started to grow, and some others just failed, right? Now, what could be responsible for the failure? There is no way I can know because I'm not a professional in the agric field. But the thing is, different plants, right, were in different environments. So, and when we say environment, we are talking about the soil, right, that the plants are in the vase, right, before they were being transplanted. So different plants will have different requirements. So their ability to survive will now depend on whether they are in the right environment or not. So how does this relate to DevOps? So it is similar, right? If we look at it, the process. So now that we are familiar with this Greek explanation, right? So let's look at DevOps. Now, developers are like Home Depot, right? And when you talk about Lagbaja, who went to Home Depot to shop plants, right? They're like the operations team, say the product manager, right? They have requirements. Now, they have requirements for certain things to get done, and the developers in their respective environments are able to write codes, test the codes, and get them to work at their own location. And on getting these codes, these packages to the client's location, they fail, right? Now, there are several reasons why they will also fail, just as we have with the plants, right? So it could be that the applications are running in, definitely they are running in different environments, but what is required for the application to work in the client's location or the client's computer are not available there. So there comes the DevOps engineer, right? DevOps engineer is able to help resolve issues like this, right? So because The DevOps engineer understands the different tools, is able to bridge the gap between the development team and the operations team, right? Is able to bridge the gap because he understands the languages of both parties, right? So he's able to bridge the gap and get things to work and understand what could be missing in the different environments that would have made the applications to fail, okay? So now that is the DevOps engineer, right? Is able to resolve these issues and make things work because he understands the languages on both sides. So with this story, let's look at some popular models used in the software development cycle, right? We've been talking about developers, we've been talking about the operations team, also talked about the DevOps professional, right? So let's start by looking at some models used in the software development lifecycle, okay? So there's a waterfall model, right, which is the like the traditional model, right? So the waterfall model breaks it down into 6 phases, right? 6 phases. Now, the first phase that we have here is the requirements gathering phase. So as the name suggests, requirements gathering phase. Solution architects, the technical leads, right? They will go and meet the clients to understand the requirements for the project, right? The requirements of the project. What is it you want to achieve? Okay, we want you to develop an application that can do X, Y, and Z, right? So those are the requirements. So the technical leads and the solution architects, they approach the clients to get information regarding what the client needs done. That's requirement gathering phase. So after this requirement gathering phase, what happens, right? The next thing is that we have the design phase. Here we have these guys that have met the clients. They go back, right, to their office, right? And they try to document all those requirements and specifications required, right? So now they've seen A, B, X, Y, Z needs to be done. We need an application to do this, right? So they'll now go and look at putting together documentation, right, on the information they've been able to gather, right? So they try to put it together so that they can have all the requirements documented and also the system's requirements. What are those things that are required to achieve the client's requirements? So all that will be done by the solutions architect, right, and the technical leads. So after this stage, what happens, right? We see implementation. So work starts to get done, right? Work starts to get done. So at this stage, you see that the developers will now start writing codes based on the documentation provided by the solutions architects, by the technical leads, right? They start to write codes, right? That's the implementation stage, right? They start to write codes, that source code, unit test cases, and build scripts. All of this we'll get to understand in the course of the program, okay? So after writing all the codes required, right? Then we see the next stage being the testing phase, right? As the name suggests, whatever is being done, right? Whatever is being worked on, right? The source codes and all of that, right? For the application are being tested, right? They are being tested to see that the development is in line with the requirement. Look at it. We got requirements, gathered requirements. There's a design, documentation of the requirements. And these guys, developers, will write codes based on the requirements documented. Now, the QA team will test whatever has been written that they are in line with the requirement. Otherwise, client is asking for XYZ and you are giving ABC, right? Definitely, we are not on track, right? So testing phase will try to make that happen, right? To see that what is being implemented is in line with the design based on the requirements gathered, okay? So now that's testing phase. Now, after testing, we'll have the middleware admin, right? The middleware admin will take care of deploying the applications, right? And releasing it to the market. So deployment is like releasing to the market, right? So when it is being released, right, users will try it out, and if there are errors, they'll provide feedback, and that's what is taken care of in the maintenance state, in the maintenance phase. So at the maintenance phase, what is being deployed for use, right, are being used, and if there are issues that require resolution, they can get handled by the guys in the support team. Okay, now that we've looked at the different phases, right, you say that at each of these phases, right, at each of these, okay, for each phase that we have here, we have different team members, right? We have different team members. At the first stage, we see that we have the team lead, right? We have the technical leads, we have the solution architects gathering information. And in the second phase too, they're also involved in the documentation of the requirements, right? Both system requirements and what the clients require, right? Then at this stage, somebody else gets the baton, right? The developers, they start to work. It could take a long time, right? Depending on the project, right? It could take a while for this to get done, right? For a complete writing of codes to get done, it's going to take a while, right? Then after that, the baton gets passed to the QA and the testing team, right? That test the code to ensure that they're in line with the requirements, right? So the testing team gets the baton, right? Then afterwards, baton is passed to the middleware admin, right? Before the support team gets hold of the baton, right? So if you look at this waterfall model, you realize that there's poor utilization of manpower, right? Poor utilization of manpower. Because at this level, where we have just the team lead and solutions architect working, the other guys are idle, right? There's plenty of idle time, right? Then when the baton gets passed to these guys get into idle mode, right? And so on and so forth, right? So you see that there is poor utilization of resources, manpower resources. Now, aside this, another thing you notice is that for some of these phases, some are longer than the others, right? Oh, the process of gathering requirements, process of documenting the requirements and all of that. Then you see the developers writing codes. This will take some time, right? And you see all of this taking time, right? The clients, because the truth is, if you look at projects, right, requirements change at a very fast pace, right? Maybe I'm excited by something right now, and along the line, maybe after 3 days, I have some other ideas to chip in, right? You can see the project requirement is fast changing, but the time to deliver is long. So that is a huge challenge on its own, right? And the clients will not even have the opportunity to discover problems until release, right? Until this time when the application is deployed, right? So the client does not have an opportunity to chip in and see, oh, there's a problem with my idea, at the point of dishing out the idea, they might just have a thought of X, Y, Z, whereas there could be X, X, Y, and Z, Z, right? Maybe something requiring improvement in respect to Z, right? But at that moment, they don't have it. But since it takes time to deliver, right, you realize that even by the time the project is delivered, the excitement is not as much as it was, right, from the clients. Okay, so these are some shortfalls, some shortcomings of the waterfall model. Now, based on these shortcomings, another kind of model, right, came to light, right, which is referred to as the Agile Methodology. Okay, the Agile Methodology. Agile, right? You can see Agile, Agile. So Agile Methodology is either based on the Scrum model or the Kanban model. Okay, the Scrum model and the Kanban model. Okay, so these are some models that the Agile methodology is based on. So as we explain the different models, we'll get to see the agility of the methodology. Okay, so now looking at Scrum model. Scrum model is based on sprints, okay? Scrum model is based on sprints, okay? It's based on sprints. So when you say sprints, sprints are like short timelines, right? Short timelines, usually maybe 2 weeks, but it could be maybe 1 week or 4 weeks, right? Depending on the project. So they are just short timelines, okay? Sprints are short timelines, which will be different from organization to organization. Short timelines under which certain component of the project is expected to be completed, right? So those are sprints, right? So it could be sprints of 2 weeks, right? So within those 2 weeks, it could be that the component of the project that should be completed will be the login, right? The login area, right? Of the project could be completed. A certain component, right? Depending, let's say we are looking at a website, right? And of the whole structure, okay, let's look at it from a building, right? Of the whole building, say, okay, um, on the main floor, complete the living area, right? So you have 2 weeks to complete that. That's the project, right? You have 2 weeks to complete that component of the whole project, right? So that's how you look at sprints, the short timelines, right? Required to complete a certain portion of the project. So what this does is that compared to the waterfall model, right? When projects are completed within a short timeline, components of a project are completed within a short timeline, you get to understand, to see the kind of work that is being done and how the work can be improved on. Then the client gets to see what has been completed, right? Goes there and says, oh, I'm not sure I like the way this wall is. Okay, for subsequent work, can we make sure we make it smoother, or we want to get a certain degree, or so different things could come up at that level, right? So the client gets to see what is going, as an idea of what is going to be delivered when the whole work is delivered, then has an opportunity to provide an input, right? So that is one of the benefits of the sprints, right? The sprints, right? When work is completed within a certain timeline, right? So now, the amount of work that can be completed within the sprint, right, will determine on the team velocity. So we're just picking the terms one after the other so that we can relate with them well. Team velocity, right? So the team velocity is the team velocity is the measure of the amount of work that a team can complete within a single sprint. Okay, so let's say a team comprises 10 people, right? And they are supposed to work on a particular space, right? So the measure of the amount of work that can be completed will be referred to as team velocity. Okay, so if the total size of that room, of that space, is supposed to be completed by 10 people in 2 weeks, that's the sprint. Let's assume that the sprint is 2 weeks. So if they are just 8, you'll be looking at the work being completed up to a certain percentage, right? So that you can say, oh, work up to maybe 80% should be completed, within the 2 weeks, right? So at the end of the day, there's a basis for measuring the work completed based on the available number of team members, right? Team members available to work on the project. So that is team velocity. So now, when you look at this way, the team members are working, right? So with Scrum, there are plenty of meetings, right? There are plenty of meetings, and there's something very important about the Scrum model, right? So the Scrum model uses something called the Scrum board, okay? The Scrum board, okay? Scrum board. So the Scrum model, for Scrum model, teams, right, use the Scrum boards, right, to display some important information about their projects, right? So some of the information that will be displayed in the Scrum board will include to do, in progress, and completed. So let's look at those guys working on the living room of the building, right? So they'll have a board to say, oh, completed, we put up the walls, right? So what is outstanding is probably the ceiling, right? The painting and some other things, right? So they'll have a Scrum board detailing everything that needs to be done, the work that is in progress, and the work that is completed, so that they can move items from maybe to do to in progress and to completed, right? So the Scrum board will give them an opportunity to see the progress, right? Without even having to ask, oh, where are you on this? There's always a Scrum board to help with that information, right? Now, aside this, Scrum is usually associated with meetings, right? There are plenty of meetings, right? With Scrum meetings. You can say Scrum meetings. Scrum meetings that need to get done, right? There are several Scrum meetings that need to get done. So let's take a look at some of the meetings that are usually associated with the Scrum model, right? With Scrum model, we have the sprint planning meeting, right? Sprint, right? You know, we have short timelines of meetings, short timelines when projects, certain components of the project are supposed to be finished, right? Completed. So before every of this meeting, there is the sprint planning meeting. Like, oh, we have a meeting to prepare for these 2 weeks, right? So the meeting is going to have the product manager and the members of the team to discuss what the expectations are of the sprint and what needs to be done and the timeline and each person's role. All those details will be discussed at the Scrum planning meeting, right? Sprint planning meeting, right? So that's one of the meetings that will get done. So another meeting that gets done every day, right, will be the daily stand-up meeting, right? This daily stand-up meeting, they are held to provide updates on what has been done, what will be done, and the challenges faced, right? Because definitely uh, we have to complete this in 2 weeks. We need to know what each person has done, okay? What does each person have outstanding? And if there are challenges, what are the challenges so that support can be rendered by other team members, right? It's a team sport. So we have the daily stand-up meeting. So now we have the sprint review meeting, right? The sprint review meeting will be held at the completion of the sprint, where non-members will be welcomed, like the product manager, to see what has been done, what has been delivered, and all of that. Then afterwards, there will be the sprint retrospective meeting, right? The sprint retrospective meeting. In this meeting, only members are welcome, right? So we don't expect to see the product manager there because there we're trying to have a meeting to see, oh, to discuss what we did well in the last sprint and what wasn't done well, because we also need to know that so that we can see how we should start working on improving, right? On improving while working on subsequent sprints, okay? So there could also be product backlog refinement meeting, right? Which will discuss how to work on backlogs and how to refine what has been delivered in the past or work on something that wasn't well done in previous sprints, okay? So those are the different meetings, Scrum meetings that we could have. We've discussed sprints, right? Which is the short timelines, right? We've discussed team velocity, the amount of work, the measure of work that can be completed by a team, right, in a sprint. We've talked about the Scrum boards, right, that details everything that needs to be done, what is in progress, and what has been completed. And the different meetings, right, that we could have, different Scrum meetings, okay? Now, looking at Scrum model, right, we've discussed timelines and all of this, compared to the waterfall model that we described earlier, you can see this is more agile, right? This is like an agile version, right, of what we had here, where we have to wait till the end to see what has been done. You can see right here, work is getting done, client is getting feedback, and client is giving input, right? So you can see this is agile. You can see the agility of the methodology, right? So everything we have here, we still get done, right? You can see, if you look at the requirements gathering phase, you can see where you have uh, the sprint planning meeting. You can see all of those things. You see, everything we get done in as short as possible, right? So that is Scrum Model, right, under the Agile methodology. Now, there's another model called the Kanban model, okay? The Kanban model is similar to the Scrum model, except that it doesn't have timelines set, right? You see, it doesn't have timelines set, right? So that's the difference between the Kanban and the Scrum model, right? The Kanban model and the Scrum model. So the Scrum model uses short timelines like sprints. There's a time set, right? There's a time set for certain things to get done, right? But the Kanban model uses boards, right? They use board. In Kanban model, boards are also utilized, right? To see what is being done, the progress, what is in progress, and what has been completed. Okay, so that is Kanban methodology for you, right? So unlike Scrum that has timeline set and all of that, so this does not have all those in place, okay? So that's the Kanban model for you. So it is important we take note of this, right? Because in DevOps, this is the practice we'll be adopting, right? The Agile methodology. So we'll get to see it as we go into the program, but bear in mind that these phases are also important in understanding the software development lifecycle. But we'll be adhering to or working with the Agile methodology, right, in DevOps, okay? So now that we've looked at that, we'll also notice something. Why DevOps? Why do we even need DevOps? This looks perfect to an extent, right? Okay, but if you look at this, it's usually prone to some mistakes because of the very short timelines, right, that have been set, and because of the mistakes that it is prone to, right? You know, projects have short timelines to get completed, right? And because of that short timeline, the rush and all of that, there's likely going to be mistakes, right? So now, because of what we have here, the methodology is great. However, because of the rush and all of that, led to the introduction of DevOps. Okay, so now we can look at what is DevOps. So let's take a look at what we have here. What is DevOps? Okay, so what is DevOps? DevOps refers to the methodology and strategy that is used to introduce automation to an environment to ensure that a product or a project or a certain software is delivered efficiently and effectively. Okay, so you can see the methodology that brings development and operations team together, right? Which we've seen at the beginning, and to achieve a common goal through automation. Okay, and the common goal here is delivering projects on time and within budget. Okay, so now to achieve all of this, right, there are certain tools that will be used to achieve automation, right? You see, we are trying to look at how we can introduce a strategy that brings together development and operations team together, right? To achieve common goal through automation, right? Now, to achieve this automation, certain tools will be employed, right? So all these tools that will be employed are the tools we'll be discussing, right, in the course of this program. So the tools will be discussed in the course of this program. So now look at it. There are tools like Git, Jenkins, Ansible, right? And many more. We have the tools detailed down here. Okay, let's check our curriculum. So these are the tools we'll be covering, right? We'll be looking at Git, right? Maven, Tomcat. We'll be looking at web servers like Apache HTTPD, right? Web server. Looking at Nginx, SonarQube, right? For code quality analysis. We'll be looking at Nexus. For artifact repository, we'll be looking at Jenkins. That's the automation tool, right? We're looking at AWS. That's Amazon Web Services, right? As a cloud platform. We'll be looking at Terraform for provisioning infrastructure. We'll be looking at Ansible for configuration management. We'll be looking at New Relic for monitoring, right? Looking at Docker for containerization. We'll be looking at Kubernetes for orchestrating these containers, right? We'll be looking at M also for being the package manager for Kubernetes. Then we'll be looking at Prometheus for monitoring and Grafana for visualization. So these are some of the DevOps tools we'll be learning. We'll also be learning Linux, right? Because most of these tools will be used on the Linux platform, right? Linux operating system, because that is what most organizations use. And to speed up our process, right? Instead of having to run commands one by one on the Linux server, we want to learn shell scripting as well to automate some processes. Okay, so this will be some of the things we'll be covering, and the class starts on February 4th, and it's going to hold every Saturday and Sunday at 4 p.m. EST. So this from today, right? So there's a countdown. So it's going to be on February 4th. So now let's look at DevOps methodologies. Let's look at some of the tools that we'll get to learn in the course of this program, right? But before then, let's look at the different stakeholders, right? Let's look at different stakeholders. So different stakeholders will include the product manager, which we've talked about, right? Talk about the developers who write the codes, right? They write the codes, unit test cases, and the build scripts, right? Then you as the DevOps professional, then you have QA managers, you have testers, then you have the support and the incident management team, right? So these are the stakeholders, right, in the software development lifecycle, which we've also discussed in the past, okay? So now we've looked at the different tools and what the different tools are used for, okay? Before we go into this, let's take a look at, I'd like us to look at the flow charts we have within we've talked about tools. Let's see how we can map all these tools together to achieve what we want to achieve, okay? So before then, we want to look at different architectures that we could have, right? Let's look at different architectures that we could have. Different architectures. Let's just look at it here. So we have the monolithic application architecture, right? And down here, we have the microservice application architecture. So what is the difference between the monolithic application architecture and the microservice application architecture? Okay, so in monolithic application architecture, if you look at some platforms, right, I see that the platform has login area, right? It also has user management area. It has an area for reports. It has an area for admin, right? On a single website, right? So these different areas on the website, right, are referred to as modules, right? Different modules, where login module, you can have user module, you can have report module, you can have admin module, you can have the shopping module, right? You have all the different modules, right? Product modules and all of that. So where you have all these modules lumped together as one mono, right? Monolithic. You have them lumped up as one and deployed as a single application, right? You have a monolithic application architecture. Then in a situation where you have each of these modules we've talked about, the user module, the login module, the report module, the admin module, you have them deployed separately, right? In that situation, you have a microservice, small service, right? Microservice application architecture, okay? So that's the difference between monolithic and microservice architecture. So now, why will anybody want to consider microservice when we could just lump it as one, right? So there are several reasons which we'll get to know in the course of the program, but let's just take it as this. If you run as monolithic, if there's a problem with one, it means there's a problem with all, right? But with microservice, if there's a problem with one, it doesn't mean that others will not work. The website will still be functioning, except that the login area is not working, and that can be fixed. And what that does is it helps the organization stay in good light, right? Because no people will hardly notice, except people that are trying to log in, right? That the site is down. But if it is monolithic, just single, right? And there's a problem, it means everything goes down. Okay, so that is a difference, a major difference, right? Or why will someone choose microservice architecture over monolithic architecture? Okay, now looking at all the tools we've described, right? You know, we mentioned several tools, right? We don't want it to look as if um, it's anything difficult, right? Now, once we look at these different architectures, right, we can look at these architectures and try to see how each of these tools come in and what each of these tools do, right? So now we know the difference between the monolithic application architecture and the microservice application architecture. Now, let's start with monolithic, right? We know that it's the developers that write codes, they write unit test cases, they write build scripts, right? So when they write these scripts, they commit the codes, right, to a source code manager, right? Which could be GitHub, Bitbucket, you know, it could be any source code manager, right? That is being used by the organization. So that is a tool, right? We'll be looking at GitHub. We'll also be touching Bitbucket a bit, right? Just a bit, right? So there's also GitLab, depending, right? So codes that are written by developers will be committed to this source code manager, right? So now this source code manager will be used to store the source codes, right? Now, there is Jenkins, right? And it could be Bamboo, it could be any other CI/CD tool, right? This tool will pull code from, you know, the code that was committed by the developers to the source code management, GitHub, for example. The code will get pulled by a tool like Jenkins, right? Or Bamboo, right? Depending on what is being used. So it will get pulled into this tool, right? So when it gets pulled into this tool, what happens? Things need to get done, right? Now, Jenkins can integrate with several other tools, right? Several other tools to achieve the automated process, okay? Now, the CI/CD tool here, Jenkins, is regarded as the automation tool, okay? So what it does is that it integrates, you can see the numbering, it integrates with a build tool depending on the kind of project we are working on. Let's say we are working on a Java-based project, right? We can use Maven for a Java-based project. We can use Gradle, or we can use Ant, okay? So Maven is very popular, so we can use Maven for a Java-based application, okay? So now, Maven can be integrated with Jenkins to do the build, okay? Okay, so this code written and committed to the source code manager, right, that has been pulled by Jenkins, we need to be made into a package, right? To build into a package. So Maven is a tool that can do the build to make this code into a package, right? It's just code, right? We want to make it function, we want to make it into something, right? So it will be built by Maven. That's, we are looking at a Java-based application, right? You can see this is Node Package Manager. It's also used, right? But not for Java-based applications, okay? So now, when this is done, you can look at the numbering tree. When the build is done, there's need for us to, because the build will be done at different environments, in different environments, right? At different branches, right? So we have the development branch, we could have the staging branch, we could have the production branch, okay? So when this initial build is done, there's need for us to run code quality analysis, right, on what is being built, right? So we'll use SonarQube for code quality analysis, okay? So SonarQube is our source code quality analysis tool to test the code, right? To see if the code has sufficient code coverage, okay? So those are things we want to consider. See if the code has sufficient code coverage, and to also see if there are bugs, right? To see, test for, to see if there are bugs, to check for vulnerabilities, right? So those are what we could achieve with SonarQube, okay? So now, once code quality analysis is done, you can see we have another tool integrated to Jenkins, right? So we could use Nexus, we could use JFrog, okay, as our Artifactory repository, okay? So whatever it is that has been built, right, we could have them stored in the Artifactory repository, right? Nexus, being an Artifactory repository, can be used for disaster management, okay? So it's used to back up artifacts, right, that have been built using Maven, okay? But everything is still integrated to Jenkins, right? Or Bamboo, as the case may be. Now, looking at the next level, right, you can see we have Tomcat, right, integrated with Jenkins. You can see everything is getting integrated to Jenkins, because in Jenkins, we automate the process of running everything, right? Running all the actions required. And we can see with Tomcat, we are able to deploy what was built, right? Remember, we built a package and we can use Tomcat to deploy the package, okay? So Tomcat, or JBoss, as JBoss/Wildfire, as it may be, is an application deployment platform, okay? So these are app server, okay? So you can see right here, we have the web servers or load balancers linking to the application servers, because this is what users of the platform are supposed to interact with. they are not supposed to interact directly with the application servers, okay? So now we'll have our application servers being monitored by monitoring tools using the likes of New Relic or Prometheus and Grafana for visualization, right? So if need be, if there's need to analyze logs, right, you can use any of these tools, the ELK stack, you can use Nagios, you can use Graylog, to analyze the logs, right? After monitoring, you've seen an issue, right? You might want to analyze the logs, right? You can use any of these tools for further log analysis, okay? Now, once a feedback is obtained, right, we can pass it through the ticketing tools, right, and provide feedback to the developers. And you can see all of this can happen within a very short while, right? So you can see we've been able to look at the flow charts, right? How we can interact within the software development lifecycle using our tools, right? These are the tools we are going to learn. And we are going to learn about how to use Jenkins. We are going to integrate with different tools and understand what each tool is for. We are going to pick each of these tools, understand what they are for, and how we can best utilize them, okay? So looking at this architecture, you can see all the processes get run, right? All the processes get run, and you can see feedback going back to developers who can now make modifications to the code and put them back in here, and the cycle goes on and on and on, and this way. That way, users can always have access almost immediately to what has been done without having to wait for months. And they can always provide their feedback, can provide feedback from users directly, right? Through ticketing tools, right? Feedback could also move from users, right, directly through the ticketing tools and to the developers. So this is the monolithic architecture. Now that we've seen the monolithic architecture, it's not significantly different from the microservice architecture, except that we look at the use of Docker containers, right? We look at Kubernetes. So just some little differences, okay? So let's run through the process without wasting much time. Developers will commit their codes, right? We are going through this again. And codes get pulled by Jenkins and integrated to Maven so that we can do our build, right? Then it also gets integrated with SonarQube for testing, right? So we can do our code quality analysis. Then the next stage is to have Docker integrated to Jenkins so that we can build Docker containers. We'll get to understand what Dockerization means, right? How we can put all these applications in Docker containers to ensure that space is optimized and we can deploy microservice applications, right? Using Docker containers, right? Then we can now do a push, right? After building the image, we can now push the image into a container repository, right? Here we talked about source code repository, right? Here we'll be talking about container repository, where we'll be pushing the images built, Docker images, into container repositories, which could also be Docker Hub, it could be Nexus, okay? It could be ECR, okay? So once we do this, we can now integrate Jenkins, integrate Kubernetes. Kubernetes is K8s to Jenkins such that the containers can get orchestrated, you can see, through a Docker pull from the container repository, okay? So we can have a Docker pull from the container repository, then the containers get orchestrated and users can access the applications, right? Using the service, right? Using the service, right? Using the service. So now, if you look at this, you can see we can monitor applications as well using Prometheus and Grafana for visualization. We can obtain feedback from users directly, right? And also provide feedback based on what has been monitored, what was discovered, right? And passed back to the developers. Also, users can provide direct feedback through using the ticketing tools and feedback provided through the developers, who will in turn work on the code and everything will happen very fast. So this way, there is no point waiting for anybody. So what we have here is that with this architecture, right, both monolithic architecture and the microservice architecture, we see that everything happens very fast, right? So we've seen how we'll be using specific DevOps tools, right, to get our work done. We'll implement principles and practices like Agile, Scrum, and Kanban, right? Because we'll be working with people. DevOps is not just about the tools, it's about the people, the collaboration, right? Working in a cohesive unit to deliver projects, right? Nobody's an island. You need everybody's effort, right? Everybody's inputs. Everybody needs to be on top of their games to get the best result, okay? So with DevOps, you also be a part of the highly skilled and organized individuals in the field of DevOps. You can see this requires plenty of organization, people working with tools and getting things done, right? And with DevOps, you can be sure of having a competitive edge in the industry. Okay, so what do you expect from this program? We expect that at the completion of the program, you might decide to specialize in the operation side of DevOps, or you want to specialize in becoming a hands-on builder of CI/CD pipelines, right? Because with automation tools, you see, when you have different plugins, right, or different tools that we've seen integrated with Jenkins, for example, you might want to build a pipeline as to how this would work, where should it pick up from, or where should it be configured with, right? So in building pipelines, it could be an area you are interested in facing, right? Then at the end of this program, you should also have acquired skills to architect and automate technologies, deploy applications, and provision infrastructure, right? So our program is structured such that even if you do not have IT background, you will succeed, right? Because we are offering a project-based training where you have hands-on, you get your hands dirty and see how things are done in real time, right? You have opportunity to practice. Then, as much as possible, we ensure that for each topic covered, we provide flashcards that you can use to study on your own. And also, we provide quizzes that you can use to test your knowledge on the topic you've covered. Then for this program, it starts on February 4th, and it's going to be on Saturdays and Sundays from 4 p.m. to 6 p.m. EST. We'll provide recorded videos of the program, right? We'll provide recorded videos so that even if you miss the class, you can always go over the videos and you can get to watch the videos over and over and over again to get a better understanding of the topic and be on top of your game. So in terms of titles, okay, let's look at curriculum. So with our curriculum, we get to understand Linux distributions like Ubuntu, Red Hat, right? We'll be working with these servers for you to understand the different Linux distributions. So Linux is an operating system that is used by most organizations because it's open source and it's a multi-user operating system. So on the particular Linux server, you can have multiple users. You can have Lagbaja, you can have Tametron, you can have Obesere, you can have whoever, right? On a particular server, okay? So also be proficient in Linux commands for various operations. We also expect you to be able to use shell scripting to carry out several operations at the end of the program. We also expect that you to have knowledge of cron tabs and cron jobs. We'll teach you all of this. They are not difficult, they are easy to learn. Then you also understand how to use a cloud server, right? Using Linux administration, right? Then you also understand the cloud architecture, familiar with several cloud platforms, AWS, GCP, Azure, but emphasis will be on AWS. You also get experience with tools, IAC tools, infrastructure as code tools like Terraform and Ansible. Then also Git and GitHub, we've talked about it. Also look at Maven, right? Also look at SonarQube, Nexus, Jenkins. Then we also look at understanding Groovy scripts, right? Understanding Groovy scripts, since we'll be involved in writing scripts for different pipelines. Okay, so then Docker, Kubernetes, Prometheus, and Grafana will also cover those, right? Now, what are the different titles, right? Job titles that you might be seeking at the completion of the program. Looking at DevOps engineer, DevOps manager, infrastructure engineer, configuration manager, site reliability engineer, build and release engineer, CI/CD engineer, right? Remember Jenkins, cloud engineer, system administrator, automation engineer. So all these are different titles you could have, right? Depending on the organization hiring, right? So what do you need? You need just the basic understanding of how to use the computer, right? Just know your computer. You send emails with computers, then you are fit to start this program. You know some basics, right, on the computer, right? So you don't need to have maybe extensive IT background or certain level of IT background, as long as you can use your computer, turn it on, turn it off, open things, open the browser, download applications. So those are the basic requirements you need to get on the program. But as I mentioned, you need to put in time on working on the quizzes, right? On working on the quizzes, on working on, let's look at what let's look at what we'll be providing, right? Let's look at the ongoing classes. Okay, so if you check curriculum, you can see we'll have recorded sessions, right? We'll have flashcards for each course. We have flashcards, right? That you can just navigate to learn, right? You can just navigate to learn. Okay, so flashcards while you're on the move, you could just work on the flashcards to learn. Okay, so apart from the flashcards, we also have quizzes. Okay, we have quizzes for each topic. For each of the topics, we have quizzes. So let's take a look at, let's move to here. Okay, so we have quizzes for each of the, you can see flashcards, quiz. Okay, so let's take a look at what the quiz is like. You can see you have the quiz, and we also have the leaderboard to see how you are doing in terms of ranking, right? You can see how you are doing, how you are performing in the quiz. We have our top performers listed down there. So you can quiz, you see your progress and all of that. So these are some of the things we are offering, okay? So we are offering quizzes. We also have projects, okay? We also have projects we are offering. So we have projects. So these are the different things we are offering. And how do you know whether DevOps is for you, right? We've mentioned it. If you have basic understanding of working with your computer, right? Then you can be sure that with our curriculum and the way our program is structured, you can be sure of succeeding in the program. So let's see if we've covered those questions we highlighted at the beginning. Let's take a look at the questions. What is DevOps, right? So now let's see why, from what we've seen, why are organizations embracing DevOps methodologies, right? They want to have success, right? With their software development, their project deployments, right? They want to have success. They want to tap into the agility and the automation capabilities, right, in the field to get the best, right, to achieve efficiency and effectiveness. And there's no organization that does not want to uh, uh, to deliver on their projects, right, at budget-friendly prices. Okay, so you can see delivering projects on time and within budgets, right? So these are some of the important reasons why organizations want to embrace DevOps, okay? So what makes the DevOps profession very attractive, right? So it's an high-paying job, right? It's an high-paying job. And aside that, you have the opportunity to work from home, right? You have the opportunity to work from home, get work-life balance, and whatever it is that you are looking for, you might be able to find it here. So let's see um, the 10 most in-demand tech jobs for 2023, okay? This from CIO.com, okay? So let's see the list. Okay, you can see DevOps engineers made the list, right? You can see the average salaries, right? The average 58th percentile. You can see 75th percentile and 25th percentile. You can see this is a guaranteed figure field. Okay, so you can see based on the average we have here, you can see it's an in-demand tech job for 2023. Okay, so this is another reason why you might want to consider DevOps. Okay, so who can become a DevOps professional, right? Know the basics. Once you know the basics once you know how to use your computer, that's all the requirements I believe you need, right? Our curriculum is structured to make you successful in the program because we have quizzes, we have flashcards, we have live classes, online classes over Zoom. We have recordings of the sessions provided so that you can go over it again and again. You have projects, you can reach out if you have any challenge, right, to the community, then we can get your questions answered. So are there many jobs out there? Yes, there are. So there are different platforms you can search for jobs, and just research on your own to see on Indeed, right? You can check LinkedIn, right? You can search LinkedIn, you can check DICE, and top recruitment firms like Robot Half, right? You can check them out to see what they have, right? So these are some of the places you can check to see the availability of DevOps jobs. So let's see, I believe with this we've covered sufficiently. And if there are further questions that are not covered in this material, please do not hesitate to reach out. You can reach out directly. You can send an email to info@becomeatechpro.com or reach out via WhatsApp or Telegram or direct messaging, right? You can call as well or message. Okay. So you can reach out to this number as well. So either via messaging or via calls. So looking forward to your enrollment. So let's take a look at, so I believe for the next 15 registrants, we have a 15% coupon code that can be applied, right, at checkout. And we also have an opportunity for payments for the cost to be spread over 6 installments, right, during the program. The program is a 6-month program, and the payment can be spread over 6 installments. Okay, so that's it. So looking forward to meeting you on February 4th. That's the first live Zoom class. So bye for now.